All right, welcome back to the drive-through. We're going straight bare minimums. I hope you can hear me, and I think you're going to be able to see this okay. Today we're talking about inscribed, I-N-S-C-R-I-B-E-D, inscribed angles, okay? So in a circle, an inscribed angle, can you read that? You can't see that black marker. Let's try a different black marker. Okay, that's better. An inscribed angle is an angle whose vertex is on the circle. Okay? Now, this is the most important thing in this lesson. If the angle is x degrees, then the intercepted arc, so I'll give this letters. So since the vertex is at C, the degrees from A to B would be 2x degrees. Okay? A very convenient way to think about this, and this is actually one of the most important facts in this section, is that if I draw a right angle that's inscribed and then create a hypotenuse, that hypotenuse, so if this is 90, what would this, the degree measure of this arc be? Do you have any idea? If this was 90, what this would be? 180. So if we inscribe a right angle, we create a diameter. This hypotenuse has to be a diameter. Can I pause this, you think? Okay, so hey, first important fact, the relationship between the angle and the arc is twice as big. And then second important fact, if you have a right angle inscribed, a semicircle, and then therefore a diameter is created, okay? Here's a common question. Maybe we could call this like the Star Trek question. Should have just brought some brand new markers, kiddo. All right, so let's say 40 degrees. What's that angle? The inscribed angle. So you just work your way one step at a time. That's right. If you know that this is 40, then this arc has to be 40 degrees. Not talking about how long it is, just what portion of the circle is. And if that's 40, then this is 20. So there's your next important fact. If you've got this Star Trek looking, do you know what Star Trek is? Then this angle is twice that angle, just like the arc is. So far, so good? All right, final important fact, and this will make sense, but it's easy to overlook this fact. If I just inscribe any quadrilateral, okay? Now, I guess I'm going to ruin the movie first. So, E, L, I, N. We'll go with Ellen. Okay? I'll ruin the movie. The angles that are across from each other are supplements. They have to add to be 180. Because think about it. Look at the arc that angle E inscribes. It goes from here to there. Big arc. But look at the arc that angle I inscribes. It goes the rest of the way around the circle. Does that make sense? So totally, E and I inscribe an entire circle together. And since a whole circle is 360, we know that if angle E was to be 100, then arc NIL would be 200, which means NEL would be 160, because it's got to be 360, and this would have to be 80. So there you go. Similarly, if this one is 85, this one would be 95. I'm trying to draw them to scale. Okay? And then the only other little fact of this, and I'm just going to draw this over here on the side, and I think this is very intuitive. Like, I don't think anyone that I teach would get this wrong. If you have two different inscribed angles, but they intersect the same arc, how is the blue angle related to the green angle?
7 degrees.
That's right, they're congruent. Okay? That's all the facts from 10-4. Boom.